Welcome back. This is the first of the two video on the topic of Grignard reaction. Okay, now Grignard reactions are very popular if you want to achieve alcohol as a final product, okay, and in very good yield. Okay, so let me summarize something on what I'm trying to get through these two videos and then actually walk you through the reaction. Okay, now the goal of a Grignard reaction is if you start with an aldehyde, okay, as your reactant, it doesn't matter what type of aldehyde. If you're starting with an aldehyde and you're going to do a Grignard reaction, which is GR, you're going to end up with a secondary alcohol as your product. Okay. Okay. If you're going to start with a ketone and you're going to perform a Grignard reaction, you're going to end up with a tertiary alcohol. Now, for those of you that have taken 330 or you're comfortable with the material from exam 1, you know what a secondary or tertiary alcohol is, right? All right, let's see if you actually get it. Now, this is kind of the typical format on how Grignard reaction works. Here is your reactant, and this is a ketone because this is a CH3, right? So this is a ketone. And typically R MgX is the actual Grignard reagent, okay? And R could be a CH3, could be a CH3CH2, it could be a benzene, it could be a cyclohexane, it could be a cyclopentane, etc., 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 okay? And then you also have an acid in the medium, okay? So X can be Cl, Br, IF, etc. So for the purpose of this particular thing, how about let's assume this RMGX be CH3MgBr. Say this is what I give you, and I give you H plus. Okay, plus the same reactant. Okay. Again, I don't need to re-emphasize to you every time that this is a CH3. Okay. All right, so what happens here is, I don't want to go through an extensive mechanism for it, but here's what has happened is, you see this carbon, I'm going to put it in a different color. Okay, you see this is the carbon containing the oxygen, the double bond O, right? So what is going to happen here is, I'm going to redraw this in red and just show you the difference and what has happened. Okay. So the MgBr attaches itself to the O, and the R, which happens to be in this case CH3, attaches itself here. So let me write that and circle them in a different color. So this is what has happened. The MgBr and the CH3 from this reactant has attached itself in different ways to this carbon containing the double bond O, right? And from here, the H plus now acts on it, and you're going to get your product as, let me write it in different color so you can see it. And then let's write this in even a different color. So this is basically your OMGBR becomes O. Now, if you see, it makes sense, right? This is a ketone, right? And we ended up with an alcohol on this carbon, which I'm going to again highlight it in black. Okay. Sorry, I don't think I chose my color. Okay. This is the active site. That's the carbon that contains the double bond O, right? Now, if you see, it contains 1, 2, 3, 4 bonds and the OH group, right? One of them is OH group and no hydrogen. So it is a tertiary alcohol, which makes sense to what I wrote here, right? Ketone under a Grignard reaction would generate in a tertiary alcohol, right? So let me stop here. So the driving point here is I could have given you anything, okay? So let's just do something off the chart really quick, okay? Say this is what I give you. Okay? Plus, say I give you, say a benzene, I give you this, okay? MgBr, okay? It's no different than what we did earlier. So what we should expect in our product is, at least in, let me write the initial phase first and then write the final product. So this is where my double bond O was. So the O should attach itself to the MgBr, and the benzene should attach itself this way, right? Keep in mind, benzene just cannot go touch this carbon. It has to attach itself through a bond. Now we can write the product. I'm going to draw that here. Hopefully I can fit it in. So this is your OH, and your benzene stays there. It doesn't move anywhere. There you go. This is still a tertiary alcohol, right? I worked 2 examples just to see how changing a substituent could get you a product. Now I can ask multiple views of problems out of this one single concept, okay? I can give you a product and ask you to design your reactants. That is, what would the R be? What would your other reactant be, which is this? I could have you design this and this to get the product that I want you to get. So I could actually give you the product and have you trace back, get the reactants that you must design the reactant to get the desired product. So in a way, you're going to act like a tailor to custom fit that product to that person. Okay, so we did ketone here. I'm going to come back with an aldehyde, and that will wrap up the Grignard reaction series of videos. All right, so stay tuned.